let's talk about the y-intercept. Remember that a point that's a y-intercept, that means that it's on the y-axis. And any point on the y-axis has an x value of 0. Now think about why that would make sense. If I draw some small little axis here, any point, whether it's here or whether it's down here or whether it's even lower, right? Any point that's on the y-axis, that means that to plot that point, I would not move any spaces to the right or any spaces to the left. I would just move up or down. So that means that any one of these points, regardless of which one I pick, will have its first coordinate, the x-coordinate, as 0. So to find the y-intercept, there's two ways you can find it. You can either look at the graph, right, because that's really easy to see. If you have a point that's on the y-axis, then that's your y-intercept. Or if you don't have a graph, like with these three, then you would plug 0 in for x and simplify, because we know that the x value is 0 when we're at a y-intercept. So let's see what that looks like. The first one we're going to do is a linear equation, and we're going to plug 0 in place of the x. So I would have times 0 plus 3, and negative 2 times 0 is 0 plus 3 equals 3. So my point, my y value would be 3. The point would be 0, 3. All right, the next equation has an x squared. It actually has a binomial squared. So that means we're dealing with a parabola. So in order to do x minus 1 squared, that means that I'm doing x minus 1 times itself, and then adding 3. So when I do that, I get 2 first, right? I'm going to do first, so I'm going to do this times this. Then I'm going to do the outer terms, this one times this one, and I'll get negative 1x. Then I'm going to do the inner terms, this one times this one, and I'll get negative 1x again. And then the last term, this one times this one, and I get positive 1. I'm going to simplify inside the parentheses by combining these two x terms. Oh, I almost forgot. We're not just simplifying here. We're plugging in 0 for x. So I did the simplifying first, but what we also could have done is just put a 0 right here. That would make this a whole lot shorter. We could also put the 0 in the spot that we're at right now. All right, so let's go back to the beginning and let's put in 0. Let me get rid of, actually I'll leave it so you can see that it would be the same either way. So if I put 0 in at the place that I am right now, I would have 2 times 0 minus 0 plus 1 plus 3, and that would give me 2 times 1 plus 3, which would give me 5. If I put 0 in from the beginning, then I would have 2 times 0 minus 1 would be negative 1 squared plus 3, which is 2 times 1 plus 3, which is also 5. But as you can see, much shorter if you plug the 0 in or right at the beginning. But this was good because it gave us a little extra practice in foiling. All right, so then this point, our y value is 5, so the point would be 0, 5. And now this last one is a trig function. It's a sine function. So we're going to plug 0 in right here, and then we're going to evaluate and simplify. So we would have 2 times the sine of, and here we would get, remember this is going to be 0. So 3 times 0 is 0, right? And then we'd have 0 minus pi over 2. So 0 minus pi over 2 would be negative pi over 2 plus 1. Now you might be thinking, well, how do I do negative pi over 2? We haven't really done that on the unit circle. When you get a negative radian measure, it just means that instead of going counterclockwise like we usually do, you go clockwise. So think about it. If I have my unit circle, and normally for pi over 2 I would start here, and I would go in this direction. That would be pi over 2. If this is negative pi over 2, that means I start here and I go in this direction. So it's the equivalent of this angle, which is 3 pi over 2. So I'm going to draw our point right there. This is the angle that we're talking about. It's 3 pi over 2. And we're going to need to know the coordinates at that point so that we know what the sign is. So the coordinates of this point would be 0, -1, right? Because we're on the unit circle. The radius is always 1 on the unit circle. So that point, to get to this point right here, I would not go to the left or right. I would just go down 1. So the point is 0, -1, which means the cosine is 0 and the sine is -1. So this is like saying 2 times the sine of 3 pi over 2. But we know that the sine of 3 pi over 2 is -1. So we would have 2 times -1 plus 1, which is -2 plus 1, which is -1. So our y-intercept would be at -1. Now, you're probably thinking, wait, that's what we saw on the graph. Exactly. So if I could just visualize, and I see that at 3 pi over 2, I'm at the y-intercept, and it's at -1, then I don't really have to go through plugging it in because remember, we have two methods. We can either look at the graph or plug 0 in for x and simplify. So if I can get it just from the graph, this is the y-intercept, then I can just be done.